Hi everyone. Today we're going to be looking at how to rationalize a denominator in a fraction. So in your notebook, please put down today's subtitle, Rationalize Denominators. The main goal of rationalizing the denominator is the following. It's to turn a denominator that's irrational into a denominator that is rational. Now what's meant by that? Well, here's a quick example. Suppose I give you a fraction with an irrational denominator, such as 2 over root 3. Root 3, as the denominator, is irrational because root 3 is a never-ending decimal number without any patterns in it. So with this irrational denominator, the goal is to turn it into the following fraction, 2 root 3 over 3. And as you can see, the denominator is now not irrational anymore. So the big question is, how do we do this? Well, to make your life easier, we're going to separate this into two very specific cases. Case 1, the easier case, is the following. It's when the denominator contains a single radical, such as the example above, 2 over square root of 3. There's one single radical in the denominator position. So what's the easiest way to turn that single radical into something that has no irrational? Well, the first thing we can do to get rid of the radical, if you think carefully about it, the easiest way to get rid of it is to square it. Or, in other words, multiply by itself. Because when you square a square root, you effectively cancel out the square root. So let's get that little note down. Cancel out the radical by squaring it. Or, in other words, multiplying it by itself. But in doing so, you have to remember one thing. You are working with a fraction here. So don't forget that. Whatever you do to the denominator, you also must do to the numerator. Here's a very quick generalization of the procedure that I just described. Suppose that you have a over square root of b, and the radical b was irrational. Well, observe how we turn the irrational root b into something that is not irrational. The easiest way to get rid of the root b is to multiply by itself. So we have a over root b, and I'm going to do it in green. I recommend you do the same thing. To get rid of the root b on the denominator, we have to multiply by root b, but to keep the equivalency, we also have to multiply the numerator by root b. And when you simplify everything, this gives us a root b all over, and root b times root b is just b. There we go. The denominator is now not irrational anymore. Let's take a look at some more concrete examples. So, I'd like to get the following down. Suppose I ask you to rationalize the denominator of the following. 6 over root 2. As you can see, root 2 is an irrational number. So let's get rid of the root 2. So we have 6 over root 2. And again, I'm going to show the multiplying by the root 2 in green. So to get rid of the root 2, we have to multiply by itself. So multiply by another root 2, and we have to do the same thing on the numerator position. So multiply by root 2, and the result that we get is the following: 6 root 2 all over 2. And as with any fraction, don't forget to reduce. The 6 over 2 can be reduced into 3 root 2. If you were to check on your calculator, our very first step, the 6 divided by root 2, it will give you the same result as 3 multiplied by root 2. Alright, now it's your turn to try one on your own. For example, and I would like you to rationalize the following. How about 7 over root 3? Go ahead, pause the video and try this one on your own. Alright, let's see how you guys did. So, I'm going to multiply everything by root 3. So 7 over root 3. Multiply the numerator and denominator by root 3. And that gives me a result of 7 root 3 over 3. And 7 over 3 does not reduce any further, so I'm done. Alright, let's try a slightly more complicated example. Suppose I asked you to rationalize the denominator in the following. 4 over 2 root 5. So, same as before. 4 over 2 root 5. I'm going to multiply the denominator and the numerator by root 5. And that will give us 4 root 5 over 2 times 5. Because remember, root 5 times root 5 is 5, and the multiply by 2 was always there. We didn't deal with it yet. Let's finish it up. That gives us 4 root 5 all over 10. And pay attention, 4 over 10 can be reduced to 2 root 5 over 5. And we're done. So this is how we handle rationalizing the denominator when the denominator contains only one single radical. Now let's continue on by looking at how to handle rationalizing the denominator if the denominator contains more than just a single radical. So it could contain multiple radicals, it could contain a combination of radicals and non-radicals. So in other words, case 2, how do we handle it if the denominator contains a sum or difference of radicals? So it could look something like this. Example, suppose I have 5 over root 6 plus 2. As you can see, the denominator contains more than just a single radical. Well, this situation is actually very easy to handle. The only thing we really have to do is the following. Multiply the denominator by its conjugate. The big question is, why does this work? Well, it works if you remember the properties of multiplying polynomials. Specifically, when you multiply two conjugates together, suppose you have a plus b multiplied by a minus b, you get a squared minus b squared. The biggest thing is notice that the squaring action will eliminate any radicals. So, in general terms, it looks like the following. Suppose that you have a fraction a over root b plus root c. Well, when you multiply by its conjugate, a over root b plus root c, I'm going to put the conjugate in green. I suggest you do the same thing. So multiplied by root b minus root c, that's its conjugate. Now don't forget, whatever you do to the denominator, you must do to the numerator. So the top must also be multiplied by root b minus root c. And this will result in the following. A multiplied by root b minus root c all over And here's where the magic happens. B minus C. Let's take a look at a more concrete example. Suppose I asked you to rationalize the denominator in the following fraction. 5 over root 6 plus 2. Well, let's multiply the entire fraction by the conjugate of the denominator. So that'll be 5 over root 6 plus 2. I'm going to do it in green. I suggest you do the same thing in an important color, please. So, multiplied the bottom by root 6 minus 2. Don't forget the numerator. Multiplied also by root 6 minus 2. And let's see what this gives us. This will give us 5 root 6 minus 10 all over 6 minus 4. And one final simplification, 5 root 6 minus 10 all over 2. As you can see, the denominator is now not irrational anymore. Let's try another example. I would like for you to try this one on your own. Suppose I asked you to rationalize the denominator in the following. 7 over root 5 minus root 3. Go ahead, pause the video and try it now. Alright, let's see how you guys did. So I'm going to start off by multiplying the entire fraction by the conjugate of the denominator. So it'll start out by looking like this. 7 over root 5 minus root 3. Again, I'm going to do it in green. So, multiply the denominator by root 5 plus 3. Sorry, root 3. Don't forget to do the same thing to the numerator. So multiply by root 5 plus root 3. And that'll give us 7 root 5 plus 7 root 3 all over 5 minus 3. And one final reduction. That will give us 7 root 5 plus 7 root 3 all over 2. And we are done. As you can see, it's slightly more work, but it's hardly any more complicated. And that's it, ladies and gentlemen. That's all there is to rationalizing the denominators.